Welcome back to the deep dive. For millennia, the disappearance of the Neanderthals has been this huge mystery.
It really is.
We usually hear the big stories, right? Like, was it a sudden ice age? Was it this brutal competition with us, with Homo sapiens?
Or just that their populations were too small and fragile. Those are the big three.
Okay, let's unpack this, because today we are looking at a mathematical model that suggests something much quieter, something called genetic dilution.
That's it, exactly. Our mission here is to sort of step away from those big catastrophe narratives.
Right.
And instead look at the evidence that suggests it was a sustained, even tiny amount of gene flow that was the real driver. A kind of, quiet assimilation over thousands of years.
So the sources mentioned four main ideas: demographics, environment, competition, and this assimilation idea. Why do we even need this new model if we have the others?
Well, because this model doesn't require us to be the superior species.
Yeah.
It falls under assimilation, but it's grounded in something the authors call neutral species drift.
Neutral drift. What does that mean in plain English? No advantage for us.
Precisely.
Yeah.
We don't have to assume modern humans had better tools or were smarter or anything like that. We don't need a plague or a volcano. The whole premise is just demography.
Numbers.
Just numbers. Homo sapiens was a vastly larger species, maybe, 10 or even 100 times bigger than the entire Neanderthal population, which is probably only in the thousands.
But hold on, if our population was that much bigger, doesn't that sort of imply we were doing something better?
You'd think so, but that's the power of the map here. The model doesn't need it. Think of it like a huge river constantly feeding into a very small pond.
Okay.
The model assumes these small but regular migrations of modern humans into Neanderthal groups. A constant small trickle from this. Well, this basically infinite reservoir of Homo sapiens.
So not an invasion, more like a slow leak.
A slow leak is a great way to put it. And what's fascinating here is that even though these groups were small, they acted like these recursive genetic waves. The offspring would then interbreed within the Neanderthal tribe.
Right.
And so cycle after cycle, that river water just slowly but surely changes the makeup of the pond until it's not really a pond anymore. It's just part of the river.
So you're saying we didn't wipe them out. We sort of loved them into genetic oblivion. That's a huge twist on the old story.
It is a twist, yeah.
How long would something like that even take?
And that's the amazing part. The time frame the model spits out lines up perfectly with the archaeology. It shows that an almost complete genetic replacement could happen in about 10,000 to 30,000 years.
Wow. And the number of immigrants, did it have to be large?
Not at all. And this is the real aha moment in the paper. The immigration fraction, the percentage of newcomers per generation, only needed to be tiny.
How tiny?
We're talking less than 1%, maybe even less. Just a few individuals wandering into a new group. Every generation was enough.
So it's not really extinction then, it's assimilation.
Exactly. It's less like a war and more like a slow corporate merger where one company just completely absorbs the other. And that's probably why, if you're listening, you only carry those small traces of Neanderthal DNA today.
So what does this all mean then? What's the big takeaway?
Well, the big implication is that this model sets what you could call a conservative baseline. Meaning, if this genetic replacement can happen without any selective advantage for modern humans, just on numbers alone,
then any advantage we did have would have just poured fuel on the fire.
it would just acted as an accelerator.
Yeah.
Exactly. The dilution model shows that demography was a powerful enough engine all by itself. It doesn't rule other factors out,
Right.
but it shows they weren't strictly necessary.
Fascinating.
And here's a final thought for you to chew on. The authors suggest this same mathematical framework, this genetic dilution model, used for an ancient human species.
Yeah.
That can be adapted today to analyze hybridization and conservation issues in other imperiled species that are facing similar pressures from larger incoming populations. So the deep past could give us tools to manage the near future.